Okay, so we are on the last topic of Unit 5, where we have been discussing the potential situations where your tuned amplifier will oscillate. So we have taken the Y parameter model or admittance model and found out that if the resistance is going to become negative, then your circuit will never work as an amplifier. It is going to work like an oscillator. So that is what we have concluded in the last class. So we should ensure that the resistance should always be positive number. It should not go to negative, or it should not become less than zero. And the reactance part should be zero, or the inductive reactance should be cancelled by the capacitive reactance. You have to ensure the resistance is positive and the reactance part is completely cancelled out. Okay, so that is going to be the criteria for us, and that method of doing this is called as neutralization. So the method by which I am going to eliminate possibility of an amplifier becoming an oscillator is called as neutralization. So that, so see here the technique used for elimination of potential oscillations. See, they use the word potential oscillations because always these oscillations are not possible. If due to some circuital parameters, if oscillations are favorably becoming possible, then you need to eliminate, then your circuit should be able to eliminate them. That is called as neutralization. So these oscillations are not going to be coming always in your circuit, but in case if they come, your circuit should be designed in such a way that you should have components which will ensure that the oscillations are completely cancelled out. So BJT and FET are potentially unstable over some frequency range due to the feedback parameter. As I told you, you have a feedback component which will connect your input and output. Just like you remember collector to base bias, where you have a resistor between base and collector in common emitter amplifier. Base is going to be your input, collector is going to be your output. So I am going to have a resistance between base and collector. So that resistance is going to act like a feedback component. So those feedback components are the mechanism, or they are the entry points through which the oscillations might begin. Because through the feedback component, some portion of output gets mixed with your input, right? So if that portion of output which is getting mixed is going to be in phase, then it will produce a positive feedback, and then oscillations are going to start. So they are saying that BJT and FET, even though they are very good amplifiers, they still tend to become unstable over some frequency range because of this feedback component. And this feedback will be there because the biasing circuits are designed on the feedback components only, right? So I cannot completely eliminate the feedback components. So these feedback components will also be there. What additional components, if I include to my circuit, my oscillations are going to be minimized. So if this feedback is cancelled by an additional feedback that is equal in amplitude and opposite in sign, the transistor becomes unilateral and oscillations will stop. Assume this feedback is adding a positive feedback of plus 2 volt, for example, and if you ensure that you are going to add another feedback of minus 2 volt by some other mechanism, this plus 2 and minus 2 will get cancelled, which will ensure that the oscillations are not going to be formed. That's what they're saying here. See here, I am going to give one more additional feedback which is equal in amplitude but opposite in sign. That's what I said. If your feedback which is coming from your feedback component is plus 2 volt, I need to give the same 2, but it should be opposite in sign. It should be minus 2. So effectively, if I'm going to add them, it is going to become 0. So my potential oscillations are going to be completely stopped out. So this technique of introducing an equal and opposite feedback is called as neutralization. And we are going to see how we can introduce this neutralization technique in PG.